Having already removed the top half of the pump casing, the outboard bearing, and the bolts which hold the seal plate to the pump casing, the workman now draws the seal plate off the end of the shaft. So this is really the first step in disassembling the mechanical seal itself, although he's already done a substantial amount of work. Once this plate has been removed and set aside, he can then remove the remainder of the stationary portion of the seal as a unit. This is the stationary seal face, its holder, and also those springs that we saw in the drawing, which are used to establish tension on the seal face. After this has been set aside, the rotating portion of the seal is now exposed for dismantling. Now you recall that we said the rotating element of the seal on this particular pump was clamped onto the shaft. It's held in place by a two-piece clamp, which in turn is attached using a set of Allen-type set screws. So the workman makes use of an Allen wrench to loosen these 4 set screws before removing the rotating element. After all 4 of the screws have been loosened, the rotating assembly can then be slid off the shaft as a unit. So what is slid off the shaft then is the two-piece locking ring together with the rotating seal face as a unit. These components, like the others, are slid off over the end of the shaft and then set aside so that they can be further dismantled and inspected. Now that really completes the removal of the mechanical seal from the pump. However, on this particular pump, there's one further component which should be removed to allow an examination. This is a restricting bushing which is placed in the bottom of the stuffing box. Its purpose is to provide a minimum clearance around the shaft and to provide a restriction for water flow from the pump into the stuffing box or from the stuffing box back into the pump. These are not always used in conjunction with mechanical seals, but frequently are. As I said, in this case, of course, the pump was provided with one, so the workman removed this part as well to allow an examination. So in a few simple steps then, that completes the removal of a mechanical seal. The next job is to further dismantle these parts and examine them for evidence of wear. The first parts that the workman examines are those associated with the rotating portion of the seal. First, he removes the 4 set screws, which hold the 2 halves of the locking ring together. After these set screws have been removed and set aside, he can then separate the 2 halves of the locking ring from the rotating seal ring. Now, once this is accomplished, each of the 3 parts is carefully examined for evidence of wear and to determine whether or not the part can be reused. Now, the function of the 2-piece locking ring is simply to clamp around the shaft and hold the rotating seal face in position. So it's unlikely that these parts would be worn. However, the seal ring itself requires a very critical examination because this is a part, obviously, that will wear over a period of time. Now, in the case of this seal, even though excessive leak-off had been noted, no evidence of wear or erosion was found on the seal face. However, the workman removes the O-ring, which was used to seal between the rotating face and the shaft, and found it badly worn. So apparently the cause of the excessive leak-off was not a failure of the seal itself, but a failure of that O-ring. After setting the seal face aside then, he then examines the restricting bushing which was placed in the stuffing box. Now this part is replaceable and therefore will be replaced with a new one upon reassembly. He then begins an examination of the stationary portions of the seal. What he's looking at right now is the stationary seal face, and he's examining the springs around that face which are used to maintain tension on the seal. He then examines the face of the seal itself and again finds no unusual wear. While there is some wear evident, the seal face can obviously be reused. Now the gasket, of course, from the seal plate is discarded and will be replaced with a new one when the seal is put back in the pump. The seal plate itself is again a part which rarely wears. So after examining the sealing surfaces to be sure there's no evidence of leakage there, he sets it aside. So as with most mechanical seals, there are two key items in our seal which needed to be checked. One is the surface of the two seal rings, the stationary ring and the rotating ring. And the other is the O-rings that are used. One O-ring here, which seals between the shaft and the rotating seal ring, and one O-ring here, which seals between the seal plate and the stationary seal ring. And if you'll recall, with our particular seal, what had failed was not a seal face, but an O-ring. And you'll frequently find that this is the case. And I've seen people actually change seal faces when they didn't need to, because the source of the leakage was really a failed O-ring. So what our workman needs to do next then is to obtain some new O-rings and a new gasket, and of course to clean up the parts of the seal before reassembly. So while he does that, what I'd like you to do is to take a break at this point and review seal removal and disassembly and inspection with your instructor. Well, in the last segment, we saw the steps involved in removing a mechanical seal from a pump, disassembling the various parts of that seal, and inspecting them to determine the reason for the excessive leak-off. And we said when we left that our workman was going to obtain the necessary new parts and clean the old parts in preparation for reassembly. Well, he's completed those steps, so let's rejoin him and see how he goes about putting the seal back together. Following the instructions in the manufacturer's instruction manual for the seal that he was rebuilding, the workman applies a small amount of grease to one end of each of the springs that are provided for the stationary seal ring before placing the springs in the openings provided on the back of the seal ring. This grease not only tends to lubricate the springs, but will also hold them in position in their openings during the assembly process. So as I said, he applies a dab of grease to the end of each of the springs before placing it in position. He then applies a small coating of grease to the O-ring, which is used in the stationary portion of the seal assembly. Now, greasing O-rings is a good practice. Again, it helps to hold them in position, and if they need to be slid over another component, such as over a pump shaft, the grease will allow them to slide smoothly and minimize the possibility of the O-ring being damaged during installation. So after applying grease to the O-ring, the workman then places it in the groove provided for it on the seal plate. Now this O-ring, you recall, forms a seal between this seal plate and the stationary seal ring to prevent leakage out of the pump at this point. He also installs a new gasket on the seal plate before then placing the stationary seal ring in its final position in the seal plate. Once this has been done, this completes the assembly of the stationary portion of the seal. This means that the entire stationary assembly can then be placed on the pump in one step at the appropriate time in the assembly procedure. Now, after completing this step, the workman then installs the first part onto the pump. And do you remember what that's going to be? That's a new restriction bushing, which is installed in the bottom or back of the stuffing box. On this particular pump, clear water is injected into the stuffing box because the pump is used to pump abrasive fluid, which would damage the seal. This bushing limits the quantity of that clear water which goes on into the pump. The clear water, of course, is the only water which passes up to and through the seal. So the workman installs a new restriction bushing onto the pump, being sure that it's properly seated in the stuffing box. He then proceeds to begin assembly of what will become the rotating element of the seal. And the first step here is again to apply grease to an O-ring. Now this is the O-ring which seals between the rotating seal face and the pump shaft. You recall this is the O-ring that was found to be failed during disassembly. So after applying grease to the O-ring, he places it in the groove provided in the rotating seal face. Now, as you can imagine, the position of the rotating element of the seal on the shaft is very critical because it's going to affect the clearances in the seal. Now, in some pump applications, there will be a shoulder on the shaft to establish the position of the rotating portion of the seal. In this particular pump, such a shoulder is not provided. Instead, the seal is designed such that the rotating portion of the seal is installed on the shaft a specific distance into the stuffing box. So to establish that distance, the workman first sprays a small amount of machinist blue on the surface of the parting flange of the pump. Then, after checking the proper dimension from the manufacturer's material on the seal, he then measures that distance into the stuffing box and scribes a mark on the parting flange. Now, this mark will be used as a reference mark in positioning the rotating element of the seal. He then repeats the same operation on the parting flange on the opposite side of the pump shaft. After placing these reference marks on the flange, he is then ready to complete the assembly of the rotating portion of the seal. Now, you recall that this portion of the seal is made up of a total of 3 parts: the rotating seal ring and a 2-piece locking ring which clamps onto the pump shaft. So he places the seal ring in the groove provided in 1/2 of the locking ring, and then places the second half of the locking ring in position, ensuring that it engages the groove on the seal ring, and also that the alignment pins are engaged in the 2 halves of the locking ring. Then he threads in the 4 set screws which clamp the 2 halves of the locking ring together. Now, of course, he doesn't tighten them just yet. He simply threads them into position in preparation for installing the assembly on the pump. After installing all 4 of the set screws, the workman then applies a light coating of grease directly to the seal face. Now, this may or may not be a requirement on the mechanical seals that you're going to be working with. It depends on the material that the seal faces are made of, and also the type of fluid that is processed by the seal. So you should always check the manufacturer's instruction book for the seals that you're working on to determine whether or not grease should be applied to the seal faces. After placing the grease on the seal face, the workman then takes the rotating portion of the seal and places it in the proper position on the pump shaft. Now, you'll notice that he uses great care when sliding this part up onto the shaft. This is to avoid either dislodging or damaging the O-ring that's on the inside of the rotating seal ring and forms the seal between the seal ring and the shaft. Now, he slides the unit up into position by referring to the reference marks that he put on the pump flange. He slides it up until the seal face is aligned with the reference marks. And once this has been done, he then tightens the 4 set screws, locking the rotating element in position on the pump shaft. With the rotating element of the seal installed on the shaft, the workman then installs the stationary element of the seal, which, as you'll recall, goes on in one operation because the assembly steps for this portion have already been completed. So he slides it carefully up over the pump shaft to avoid dislodging the seal ring or its O-ring. Then, once the seal plate is in position and butted up against the surface of the pump casing, he installs one of the 2 bolts which hold the seal plate in position. Now, the other bolt can't be installed until the top half of the pump casing is set in place. So for this reason, neither bolt will be tightened.